and thermal analysis into the PNS, with the ability then to run operational things. So you can get what is, let's say if you're operating, you can use our software to simulate switching plant management. So how do I switch the breakers to maintain power to the lines if I need to do maintenance operation? Looking at the arc flash calculation, both on the AC side and DC sides, whether it's low voltage or medium voltage, hazard protections, optimization of the timetable based on the network. That's what we do. Now, to do that, to give you an idea of what comes into the software to be able to build that model. So again, some of it is out of the library. So we have libraries of equipment, both for the, we mentioned the roll stock before, but also the electrical equipment, but also the actual track infrastructure. So I'll share that with you. You can have a look at it, but we take all these data again. Excel, we can import KML data for GIS, and we've got OpenStreet data. We can import AutoCAD drawings, etc. So we've got tools that can also automate as much as possible the data inputs. If you're using it's on a brownfield project, if you're working in a gridfield project, using the user interface, you can model your network directly into ETAP as well. Now again, what we do is, what we're showing here essentially is a view of what the software look like. So what we have here at the top is the view of the network. So in that example, we have 2 traction substations into 2 transformers, then into the the reticulation, or the reticulation. We have a view at the bottom of the GIS. And what you're actually seeing here is, because we have a timetable, we're actually simulating where the trains are going to be, and therefore where the load is being drawn from for the different routes where the trains are running on, right? So that enables us to do what we call time series load flow. So we can do time domain studies. So based on time of the day, where the trains are located, by defining timetable, we'll be able to understand what that load is looking like on both sides of the, in that case, on the 2 substations, but the rest of the network as well. Again, we are able to, so geospatial, that the bottom view we saw, as I mentioned, we've got the ability to import data and to visualize it. And we also have a series of tools, which are just after, to be able to help with the track layouts. From there, we also are able to generate and synchronize the single line diagram. You can, again, manually then edit it or add it if you want in ETAP, or you also can automatically have layout functions to help you build that layout. So that's a better view of what's happening. So what we're doing here to run you through, so essentially we are looking at a simulation. So that's Monday morning. The color you see in the background is essentially looking at the different voltage level. So as a train moving through the different lines, we're looking at the impacts of voltage at the different substation. And again, synchronized with the GIS view, right? So that's an ability of what you're seeing through the software when you're modeling. So again, just one view about voltages, but here what we're showing is our features around energy efficiency. So the ability to then, once you have this, you can also look at inserting. So here, for example, we've modeled an energy storage system just to help improve voltage capacity, voltage drops or efficiency on the network. But we also support flywheel storage and regenerative braking too. So this is just one application of how the AC/DC unified load flow helps you, for example, size energy storage to help with energy efficiency on the network. All right, so we're just going to run through an example now, which is how does traction distribution look like? So this is how we would model it into the network, right? So 2 different ones. And we're going to look at the AC system from memory, so DC traction system. So essentially here, this is a view you'd see in ETAP, where you're modeling all your different catenaries, your breakers, your rectifiers, and your transformers. Now, what that enables you to do is, again, as we are working through we can actually model all the different equipment, including the booster transformers and the auto transformers. And essentially, yeah, let me skip through that. So essentially, once we have that as well, here we're just showing you the features I've mentioned before, which is when we import data, we can then edit all the different tracks. We can put routes on top of the tracks as well, and very easily also just adapt what's running on. Again, if you have a software or if your customer have softwares where they have all the timetables based on the routes, we can import that from Excel. We can also edit the train schedule and the train configuration at every level. Okay, again, we have libraries of stocks. When we do the modeling, so maybe I'm going to stop here. First of all, do you have any question on the basic of what I mentioned, which is our software is enabling you to do AC, DC, load flow, short circuits, arc flash, and time domain studies? Do you have any question on that to start with?
For now, maybe no. Yeah, please continue.
No problem. All right, so I'll continue. So here, what we're looking at is actually a voltage dependent modeling based. So for every train, we mentioned the rolling stock library, but also what we can show is the equivalent circuits based on speed and voltages for the locomotive and the motors. So every time we model something, we can also model the trains. And as you said before, right, because we have the timetable, we have the speed of them, the coasting speed, etc. We actually can then look at what is going to be the voltage at every level of the locomotives. And again, stock library, if you can also configure it, or you can add your own road stock libraries as well. In addition to that, we also have we also have model based on the British standards. So 5388, which is one of the standards that's been used. That's what you apply, what you refer to in Indonesia when you design your systems. We're also able to look at, as I mentioned before, right? Either, let's say if today we can model the onboard resistors, if it's what you're using for dissipation when you're braking, or we can also look at regenerative braking back into the network as well. All right. Again, coasting roads, so we can, have parameters for the different profiles of rolling stock to give you the coasting speed based on freights or passengers, etc. Right. Another ability, some of the equipment we mentioned. So I mentioned energy storage before. Other assets we can model. So StatCom being another one for power quality. I do not know if you have a big drive to insert renewable energy, but our software can also be used to model solar, which is sometimes what we find on top of railway stations. And of course, because our software is also used, we can do other type of generations, whether it's conventional generation, wind generation, solar energy storage, as I mentioned before. But we do also support StatCom too. So now we're just going to look at what we call as the essentially the automated modeling. Again, same thing for the rectifier. We have a library of manufacturers. Once again, every time something is not in the library, you can also create your own based on manufacturer data, or you can just pick from your experience what the load is. So again, we can put the rectifier characteristic in that helps us with the model. That's going to help us also then model all the different bits and pieces that goes into traction substation and the switching station as well. Right. So we can model every one of these equipments based on that. All right. I'm just going to go to, here we are. So one thing that is also quite important when you size your network or you're trying to optimize your network, whether you're optimizing for size or you're optimizing for energy efficiency on an existing one. So trying to find opportunities where energy storage may be able to help with voltage, or looking at whether or not switching from resistor to regenerative braking may be able to help. One of the things is train scheduling. So part of our model is actually, as I mentioned before, based on the train schedule. You can define train schedules based on different days of the week, the weekends and the holidays. You can consider arrival, depart time, the time they're waiting at a station. And then we will calculate automatically the trip time calculations. Again, if your customer is using third-party software to do all the scheduling, we can just import that directly via Excel as well. And that will be used to then derive what is going to be our load, our different voltages, and power requirements on the network. So we have a wizard. So that's just an example of a wizard that shows how, again, you can model the train. So a train can have different configurations, whether or not they have the same number of carriage, for example, or they're a freight train, or they're a passenger train. And then, again, assign them to different routes on the network, and then to different days as well. And then what we're going to look at is then we can look at the performance calculation for different trains and the simulation options. So essentially, when we talk about train, let me just hide that. Sorry. When we talk about train performance calculations, we can take third-party data in, like signaling data. We talk about timetable already at scale. We can, define different scenarios, whether it's under normal condition. We can go and generate random distribution and perturbation if you want to. Things like interlocking data. So if you have interlockings between different configuration of the power network, these can be done. The network. We can go into conflict resolution, and essentially then we just run through looking at what are the cumulative loads. So depending, on the DC side and the AC side, look at different power calculations, and then determine and look from there. Do you need do you have a gap in power supply? Do you need to have locations for new substations? Let's say if you're trying to expand your network or add more trains to the network, looking for what we call weak spots in the timetable. So either the way your network is currently scheduled or your trains are currently scheduled, is there times where that schedule is actually putting pressure on the network by trying to draw too much power, so dropping voltages, etc. So then you can also model harmonics. So is there any distortion and validation of what the grid may impose or what your own standard may be? And then lastly, when you're doing this, you can do it in what we call offline mode. So your desktop analysis, but also we can connect with the SCADA or the real-time system, that acquisition system, and then we can run that in real time as well. So we can actually look at the performances in real time as we get updates from the different systems, where the trains are at. So for example, one of the good things is if you're starting to experience delays, helping, scheduling and making sure that, can you have a late train, for example, on the same part of the network as a train that's on time? Is there going to be any constraint, etc.? So the ability to connect real-time data with the model, so the operator can be making sure that the network is not being impacted by, again, delays, potential alternative configuration of the networks, etc. So again, looking at the tractive efforts, so the load, what's the profile? So we'll see later on how we actually can input the profile in XYZ coordinates, making sure that we got the train trip times, power consumption, etc., etc. So used for simulation of upgrades. For example, if your customers in considering changing their trains from one manufacturer to another or from one range to another, we can also look at that. And we talked about regenerative braking already. Again, we're looking at power flow. So same thing, we talked about unified. So what unified means is single phase. We also can look at unbalanced three-phase modeling. But again, what we're going back to is going back to this AC/DC. Now, when we do the load flow, let's say you've designed your network, you've already selected all the equipment, so you know the protection relays you have on your network, you know the transformers, the breakers, etc. We can also make sure that these devices are sized accordingly based on the datasheets that's part of the library. And we can look for any imbalances within the network. So whether or not there is different ways that we should be reconfiguring or designing the network to avoid as much as possible unbalanced load. All the way down to, as we were showing before, the internal model of the machines that are running in the trains. So now when we look at the results of what we discussed, right, we're looking at voltage, power, energy. We're looking at the acceleration and the resistance as well. The ability to look at tractive effort and speed profile. At a substation level, we're looking at rectifiers, transformer demands, the rating of the different equipment, so breakers, bus bars, etc. Potential losses and voltage drop. And then in terms of the operation, again, checking that the schedule, so we simulate the schedules and make sure that the schedule doesn't have negative impact or reconfiguration of the schedule doesn't have any impact on the part networks that the network or infrastructure cannot support, but also optimizing that. That's just some examples. So we also have in our software a Python module that helps people then restructure the reports. But this is just example of like essentially us running different part of the trucks. So again, just sample example of what we're seeing here with speed, acceleration, all the mechanical information that is then being transformed into modeled into power information across different phases, etc. All the data can also be plotted, so we can generate reports to give to your customers. You can also look at the plots for analysis. And that also can be used by the operator as they're operating the networks, right? So here we're looking at a specific trip on a certain voltage phase and looking at the impact of the different trains and what impact it has on the voltage based on the location and distance from the feeder. Just more examples again. Right, I'm going to skip through them because we can talk about what demonstration, what we'd like to see. Before we get to validation and verification, again, is there any question on what you just seen before?
Maybe one question, yeah. For the simulation result, is there included the setting parameter for the protection relay?
Yeah, so exactly. So one of the module we have is protection coordination studies. So when you do your model, you can you add the protection relays to the network. And then you can use the tool to do all your coordination. And we generate essentially the curves as well as the setting reports.
Okay. Maybe Mr. Edo, do you have any question?
Sorry, can a track calculate harmonic calculation?
Yes. So we have a harmonic, and I was showing that before. So we have a harmonic module. So when we do the modeling, we can model the harmonics, and also we can look at mitigation, so active filters or statcoms as a way to mitigate the harmonics as well.
Okay, thank you.
Okay, maybe one more question. Yeah. For the signaling data that is required for the input of the e-tracks, yeah. Uh, I've been comparing with our simulation software that we have now. So in our simulators, we need to build the signaling system separately from this from the power simulation. Yeah. So basically, we have to work two times. Yeah. First, we need to create the, let's say, the track alignment and the station position and the gradient and etc. And then we can do the power simulation, the traction power simulation, and our software is limited to only traction power simulation. We cannot simulate any other power simulation.
Okay. Yeah. Yes. So from us, yeah, once we got that data configured in, that's what I mentioned before, and that's one of the biggest value we find, because it was already like this in the ETAP software, is the ability to do the unified power flow simulation. So then we can look at traction, AC, and DC, and we can also look at the controlling as well.
Okay, and in our traction substation design, is the power mainly used not only for the traction system but also for the auxiliary power systems like
Yes.
utility building station and for that kind of load, right?
Yeah. Yes. Essentially, again, eTracks is a module that we build on top of ETAP. ETAP is being used in the industry to do simulation of power system analysis. So by default, you have loads. So in your SLD, when you're drawing so we have customers, for example, that may have trend lines within the mining sites, and then they can also model the rest of the network with like the rest of the operations, including motors and loads. So you can model any load on any network as well. And then you just do it the way you'd assume the loads, which is, you can either have load curves or time domain, time series data you can add as well. So, for example, you could have your train station load for all the building services.
Okay, thank you very much.
No problem. Thank you very much. So now we've looked a lot at the design, engineering. We looked at the simulation. We talked a little bit about the fact that the simulation can also be connected to real-time data for the operator to have a look at and see what's happening in real time. Here, we're just going to talk about a bit of the validation that we've done and then benchmark we've done against the Senelec standards compared to eTracks. So essentially what we've done is we've done some field measurements with the customer in traction substation feeders. So that should give you a bit more information about the testing that we did. Essentially, we've compared over a 70-minute period, and you'll see that what we found was very close match runs between, and so we looked at maximum kilowatts, regenerative kilowatts, maximum current, and the voltage profile, as well as the train schedule. So we showed some of the results from the reports. So what you're seeing here, let me just make it here, this is the actual measurements. This is what we found in ETAP with the simulation. And then that's the difference between the results and the simulation. So very close results. And we're just going to go through a few tables that explains as well, right? So when we're looking at the Again, the red curve here is what was measured. What is in blue is what was modeled by our software. So we can see that we are within the vicinity of the reality. And then when we distribute it as well, in terms of the energy consumption, same thing, we're very close between simulation and reality. Something that also helps is because we can get that real-time data back in, we can also benchmark our model at any point in time. So if your customer wants to have, let's say, monthly benchmarking report, that's also something that can be done. Now, some more validation for the AC and DC systems that were done. I'll show you again Senelec. So what we're seeing here is consumer versus regeneration and the error measured. So that's the standard what ETAP has given you as well. And then looking at the voltage deviations. So again, quite accurate between Senelec and standard. And that's something that once we organize a demonstration with the product experts, you can delve a bit more in terms of how the model is done, what is calculated, and what's derived from the standard itself. So again, very low deviations. So that's just to show you that we went and did some measurements with some customers and compared our results against models, and our accuracy is quite it's good, essentially. Now, just a question before we move to the next section is how involved is LRS with the operation of the networks? Is the bulk of your work in the design, or do you also help maintain and operate networks for your customers?
Okay, we only do the design and construction. We don't do the maintenance and operation.
No problem. So I may skip a little bit on a few things. However, when you do the design and construction, do your customer have specific needs for operation technology? So do you still deliver the operational system as part of your scope, or you deliver mostly the electrical infrastructure?
Yeah, sometimes we deliver also. In most of part, it will be a separate project here, but in some others, it's in a one package project.
So, being conscious of time, I'm going to skip that part because it's less relevant, but I'm just going to talk a little bit about operations, because I think if it is part of the tender, I think it's also a value added for LRS to pitch to the end user, which is, so as I mentioned before, the ETAP software, essentially it's one software. We've talked about many different modules, whether it's unified load flow, short circuit, protection sensitivity study, harmonics, arc flash. We talked about this specialist module we built for railway, which is around GIS integration and being able to have the trend scheduling and controlling, etc. Sorry, control signals, etc. But all that sits within. So once we have that, as we're talking simulation, we can connect real-time data to it. So, and that's what we call a digital twin, because essentially it's an electrical digital twin, and one that's been used to help you design the whole network, essentially on the train line or many train lines. It also has value for the end user to not receive a delivery of the physical infrastructure, but also a digital model that they can use in operation. And that's why we call that model-based power management system. So what do we talk about? So we're talking about unified power system. So essentially it's about, where we finished before, right? We finished at the simulation, and then we can take that into, okay, now I have that model that is connected to a SCADA system, for example. So it can be a Schneider Electric SCADA, it can be any third-party SCADA system, We take that operation in, and then we can essentially get that data into the model, and it can be used for operational and planning. It can be used for training. So the Delhi Metro is actually using our system to train the operators on how to operate the electrical network. You can also use it for maintenance planning. So you can look at, okay, if I'm configuring my network for maintenance, if you need to maintain a feeder, how do I configure my network so that I can isolate, lock out, tag out that feeder to do the maintenance while I'm still operating the network? What is the impact? Do I need to schedule my trains differently, etc., etc.? There's a level around disturbance record. So if customers have requirements for disturbance record, we can either have our own disturbance recorder. We can also look at waveform from the protection relay that can be brought back into the software for analysis. And then, energy storage system monitoring and management and all sorts of things. What that means in real terms, so we talked about digital twin. I'm going to go through that, just mindful of the time. But essentially, some of the customers, goods, benefits. I think you do know your customer challenges. Yeah. So essentially, it's about what we call, so maintenance, for example, is about what we call risk based. So it's taking all the information from the field. So you may have, existing PLC systems and traction control system, protection relays, etc., that are gathered by the SCADA. We're looking at maintenance report from the ERP. So, when's the last time this was maintained, etc. Then from there, we may have counters or condition monitoring information that we're getting from SCADA as well. We can evaluate what is essentially a ranking between the probability of failure and the consequence of the failure. Then we derive risk. So what asset has a high consequence, but maybe a low probability or high probability, which tells you where do we need to maintain. Once you get into the maintenance plan, as I mentioned before, we have the model, right? So if I need to operate on a transformer, how can I configure my network? What is the impact, potential impact to the customers? So, can I run the same amount of train? Do I need to change my scheduling during this maintenance operation? And then from there, we can actually then derive the switching plan. So a customer can go and say, okay, I now understand that to maintain this, I need to close breaker A, reconfigure fit from B. Okay, what are the operations that I need to take so I can write down a switch plan to be able to issue to my operators and run on site. And then we derive that to training simulation as well. So you can do events, you can do training. So this is the example I mentioned before. So Delhi Metro Rail. As you see it here, we have an operating training system that does all the functionality I described before. Schneider Electric was providing the SCADA in that instance as well. So we connected to their SCADA to get all the information. And we were competing with Siemens, General Electric, and ABB. And we were picked because of our ability to have just the one platform to model the whole networks and the operations together, and the ability to integrate with the SCADA as well. Right. Then lastly, again, because of what we do and what we're seeing now is that model, because it's using operation, can be used for the next stage. So let's say, essentially, once you've designed a network and it's in operation, you also can reuse that model with the data, operational data, to design the next stage. Whether it's the next stage because you want to extend the network, whether the next stage because you need to look at what energy is being used and you try to optimize costs, so trying to reduce the cost of energy used. Can I optimize my schedule so that it reduces cost on electricity based on your contract? But also, as I mentioned prior, would an energy storage system help reducing the cost and the efficiency of the network? What if I, add solar, whether it's on-site or off-site, etc., etc. Distance analysis we can skip. And then again, same thing. Because we model, we can look at essentially comparing actuals versus modeled and look up for essentially what is stray current monitoring. Again, based on the measurements, we're then able to have an estimation of the location where installation is deficient. Again, same thing, visualize, archive, and analyze through time. And then I think we're going to stop here because that's communication architecture. But essentially, let me get you out of here, out of the presentation. Essentially, if I summarize, then what we saw today is that ETAP is, before I've started 35 years ago as a power system analysis software. It does everything that you can expect from a power system analysis, which is, again, from load flow, short circuit protection, harmonics, arc flash, transient studies, stability studies, etc. With then eTrucks, which is a module that is specialized for railways, that has, GIS data input, routing of the trucks, routing of the routes, configuration of the individual trains, schedulings, etc. That enables to inform the model, so we can do the unified AC/DC load flow and look at alternative solutions for energy efficiencies, whether it's regenerative braking, whether it is energy storage systems, looking at the impact of upgrades of the rolling stock, all the way down to having not just modeling the network, but also modeling the utilities and the other services next to it. That model also has value. So when using ETAP, you can also go and see your customers and inform them that you are now capable to deliver not just the physical infrastructure, but also the digital model that has benefits for them in operation, whether it's operator training system, whether it's maintenance, whether it's actually helping with just the day-to-day operations of the networks. So I'm going to pause here. I'm going to open it to see if there's any question on what we saw today. And then after I've answered the question, trying to understand and gauge the interest you may have to understand more and to see some of the features of the software, so we can organize a demonstration with our eTrucks experts. So do you have any questions to start with?
Okay. In your slide, I see that there is a report for each train power consumption, right?
Yeah.
Can it show the power consumption of the train based on the train speed? Let's say if the train goes maximum and 40 kilometers per hour, the power consumption will be like this, and then when the train goes maximum 80 kilometers per hour, and the power consumption will be like this, etc., etc.
Yes, so essentially, there's been a lot of slides that we showed, but essentially I was showing one slide where we're modeling this speed and voltage, the voltage dependent modeling. Give me 1 second, let me just share again. So yeah, the answer is yes. So let me show you here. So we have a voltage dependent modeling. So it's based on the speed. So what voltage are you drawing as well? And then you can derive the power for the different speeds. So that's for the train itself. So based on the control of the model of the, so it's based on the controls of the locomotive. So different manufacturers may control their locomotive differently. And then also based on the actual motor within the locomotive. You can define these curves, or we can take them from the manufacturers as part of the rolling stock library that we have. So that's the first aspect of it. And then you also can, on your network itself, you may have certain costing speed based on, if you're in an urban environment, you may only go to 40 km an hour. If you're in a suburban environment, you may be able to go faster. So we can model both. And that informs and help derive the trip time calculations, etc. Does that answer your question?
Okay, yes. And for the train model, yeah, eTrucks have a all train library because in Indonesia, in the mainline railway electrification tracks section is using the old one that come from Japan.
Okay. So to answer that question, if you could, I'll send just an email to follow up. If you could answer to that email and give us the model, I can tell you if it's in the library. If it's not in the library, we still can, a user can still add a rolling stock. So you can create your own library with their own user-defined curve. So then it's whether the manufacturer is able to provide. So if they're not in the library and the manufacturers provide the curves, we can add them. Otherwise, if there's any actual data, then it can be derived from there. So send me the name of the manufacturers. We can check if it's in our libraries. And if it isn't, then there's still the ability to define them manually.
Okay. Maybe after this, I will check the manufacturers of the train, the rolling stock, and maybe I will send it to you.
Yeah, thank you. Okay. Any other questions? No? Okay. So we've got a minute left. So in some of the next steps then, one, I would like to understand, do you have interest into looking at how eTracks can help you design your power system? That's the first question.
Okay. Maybe yes. We want to see how the application is working.
Okay. Is there specific in order, because we talked about a lot of different things today, is there specific areas, because I'll organize a demonstration. I just want to make sure that when we do that, we can cover what you're looking for. Is there specific areas in what you saw today that you want to make sure that we actually present that to you?
Okay, maybe first the simulation of the traction substation from the 20 kV medium voltage system into DC traction system, and we want to also have a protection coordination and short circuit study, voltage drop, and then what else? Dok, apalagi dok? Sorry, I need to talk in bahasa with my team.
Sorry, apa tadi?
Demo. And maybe also the traction substation power needs, how big we need to design the
Yes, the load flow of the study. So looking at load flow, time domain load flow, power requirement through time, helping sizing the infrastructure. Is that right? Okay.
Yes.
Yeah. DC load flow. Okay. Then you made a comment earlier, I believe it was one of your colleague around maybe having a look at how we configure the schedules, essentially timetable schedules and controlling signal. And then, so I have that. So is there anything else, or with that, I can just go back to the team, find a date where we can organize the follow-up demonstration. Is there any other question or features you want to talk
maybe about? we also want to to see the demonstration of the basic ETAP software, because let's say we never use ETAP before.
Oh, okay, no problem. Sure. So, okay, so what I'll do then is, I'll do a first, let's do that first. I'll organize first to do a basic demonstration for load flow, short circuit, protection coordination, outside of the context of traction. Let's do these first. And then after that, an arc flash. Do you do arc flash studies for your work as well?
Flash for the meantime, maybe no, yeah. It's okay. We would like to see it.
So I'll organize that first. We'll do generic demonstration. What does ETAP look like when we do power system analysis? And then I'll organize a second date where it's targeted towards e-trucks and the additional features for traction and railways. Does that work?
Yeah, okay.
Cool.
So basically, what can ETAP do, and we can see what actually we need from ETAP.
Yeah, definitely, no problem. Great. All right, so I'll go ahead. And in terms of the timeline, how soon do you want the first presentation to happen? What's your schedule looking like over this week or next week?
Next week's okay.
Next week's okay. So I'll do that for next week, and I'll come back to you with a date for the e-trucks presentation after the next one. Great.
Okay, thank you.
Thank you. All right. Thank you very much for your time. We're 5 minutes over time, so I appreciate you staying a bit longer. I apologize for going over. If there's no other question, yeah, I would like to thank you, wish you to have a good day, and we'll be in touch to organize the follow-up demonstration.
Okay, thank you.
Thank you.
All right.
Thank you.
Thank you, everyone.